So in this video, we're going to see the various ways of declaring pointers and how they are different from each other and what the meaning it conveys, how to read a complex declaration of variables using spiral rule and all we are going to see with some C programming examples. Okay, so in this slide I have shown int star A and int star B with this kind of structure, one within the parenthesis. So for this one only we are going to see the difference in this video. First, there is a rule in C which is called a spiral rule to read the complex declaration of variables. So how to read a variable? So for example, if a declaration like this char star str in square brackets, if you put up a 10 and there is a semicolon, if it's like this, you have to start always from the unknown word. Other words are known to C language. Char is a keyword, star, semicolon, square bracket, number constants, everything are known to C compiler. But str is not a keyword, it is a user defined word. So you have to start in this one and you have to read in a clockwise rule, or you can say it's a spiral rule. So whenever a bracket opens till the bracket closes, you have to spiral like this. So for example, we start from this one and there is a bracket opening, there is a bracket closing, and it has to come back here. Okay, so here they came back after the square closing. So we start from str, there is a square opening. How to read is str points to, or you can say str is a array of 10 containing pointers, each points to a character. This is how to read it. str, there is a opening, so till closing we have to proceed. So there is a closing come here. So str, there is a opening, we read this one. str is a 10 sized array, but the array contains pointers that each pointer, since it's the end, each pointer points to a character. So this is an array of pointers. What you have to remember is this is an array of pointers. Then each pointer in that array will be pointing to a character. So for array, if you want to find the size of this one, the array contains 10 pointers. One pointer size is 8 bytes. So the size of str will be 80 bytes. Okay, in the next example, you see this one. This is the declaration. You see which is the unknown one, fp. And there is unknown you can put here also. In declaration part, here also we can put say x, I can put like this, float star x. So in this unknown we are starting. Okay, so fp, we start from here. You should not go to the left side, fp, then you have to go to the right side clockwise. But suddenly I reach the closing, so that means you are going back. Okay, going back till you reach the opening, and before that opening we found the star. Okay, so fp and this will be put up together. So fp is a pointer, that's the meaning. fp is a pointer, and then you go here, there is an opening, and you see these two things has to be clubbed together, opening and this is close. fp is a pointer to a function. In this way, if a parenthesis comes after the pointer, it's a pointer for a function, that you have to know. So this is a pointer and there is a parenthesis opening, means it's a function. So in this case there is a square opening, that's a different meaning, it's array meaning. So here after the pointer, if there is a parenthesis opening, it's a function. So it's a pointer to a function. But what about the function? The function get these two as arguments. Okay, and then it returns the function. See this one, we got it now. fp is a pointer to a function. That function gets int and pointer to a float as arguments. Okay, after this ending, this pair ending, it returns a pointer to a character. So how do you say this one? fp is a pointer to a function. So basically fp is a function pointer. So fp is a function pointer, that means fp stores the address of a function. But what is that function does the function gets integer and pointer to a float as arguments, and that function returns a character pointer. Okay, so fp is a function pointer. Fp points to address of a function. That function gets these two as arguments and returns a pointer to a character. So you have to read like this: fp is a pointer to a function, the function passing integer and the pointer to a float. Okay, that function's nature is the function gets int and pointer to a float as arguments, and that function returns a pointer to a character as a return value. That means the function returns an address. That address points to a character. So what is this fp? Fp is a variable containing address. That address points to a function. That function gets these two as arguments and returns a pointer to a function. It returns a pointer to a character. Okay. So this is a spiral rule. We have to read like this. So if you apply the spiral rule in here, so we start from unknown variable. A is a multidimensional array containing integers. So this is nothing but an array of integers. So how many is elements here in the 2D array? The 2D array contains a two single D array. Single D array, each single D array contains 3 elements. How many single D? 2 single Ds. So that means 6 elements. 6 into 4, 24 will be the size allocated for this. In this case, A is a variable, or A is a 1, which is nothing but an array containing pointers to integers. Okay, so this is an array of pointers. So 3 to 6, 6 pointers are stored. So each pointer will be pointing to an integer. I'll show it with an example. Okay, so in this case, if you see integer star a 2 3, how to read this one is, now I start from unknown value, unknown variable, or unknown word here. This a is unknown 1, and I encounter closing brackets. That means we have to club this spiral. It has a spiral here. The clockwise rotation has to be happen here. So a is a pointer. Okay, a is a pointer. So a is a pointer to whom? Pointer to an array of integers. So here it's an array of integers. The array has integers, and a is pointing to that array. But in the previous case, this is the previous one. This previous case, a is an array of pointers. It's containing a group of addresses. So a is an array, but the array contents are addresses. In here, there is an array with integer contents. Okay, a is pointing to that array. So contents of arrays all integers, but a is a one single value, single address value that is pointing to the base of that integer array. Okay, that I will show you with the examples, programming examples, and some other examples also I'll show. So let us declare one array like this. Imagine I have declared a 2 and a 3 sized. Okay. What is the size of this one? Well, let's see. Int of percentage %d, size of a. Okay. What will be the size of this one? 2 into 3, 6 elements are there. 6 into 4, 24. So size of this one will be 24. Okay. So this is an array of integers. See here, this is an array of integers. Okay. Now, if I put this way, int star b 2 3. This is an array of integer pointers. Okay, so we have to say this is an array of integer pointers. This is array of integers. That's the difference. Now let's print this and see. We have to print B. What is the size of so B is a array of pointers, each of which is pointing to integers. So there are 6 elements. Each element size will be 8 bytes, because for address storage one address will be occupying 8 bytes. So it is 6 into 8, we have a 48. Okay, I'll put a backslash over here. See here. So we have 24 for this one and 48 for this. Okay. So this one will be 24 output. So here it is 48. Okay. So as you all know that if I declare something, say for example, if I declare something like a star x and y. So if I put it like this, printf, if I do percentage d for x, if I print x, what's the value for this one? This x is a pointer to integer, but y is nothing but a integer. Okay, y is not a pointer to integer, y is just a integer. Okay, y stores integer, x stores address, that address points to integer. So if I am printing x, okay, the default star size of x, if I put a size of x, because x is a pointer variable size will be 8 bytes, as you know. Okay, see here, this is 8 bytes. So 8 bytes are allocated for this, for pointer variable. But if I print this y, let's imagine we are printing this size of y, 4 bytes will be allocated because it's an integer. Okay, 4 bytes will be allocated for this. You see, 4 bytes. Okay, what is the default value present? We just want to know. See, what is this x? X is a pointer to an integer. That means x is containing address. What will be the default x and y? Let's see this. Say I'll copy paste over here. We are not gonna print the size. We will print the x and y. X we are printing, y we are printing. So default x, here default x will be, what will be the content of a pointer variable if we did not assign anything to that? It will be 1. Okay, the content of a integer variable if we did not assign anything will be 0. You see here, this is 8410, this is 10. So content of a pointer variable will be 1 default. Content of an integer variable is 0 by default if we did not initialize with anything. Okay, this is just for understanding before getting into the exact difference what we are talking about. Okay, so now I'll just remove these parts, as you might have known the basics. Okay, now here we are coming back to this. It's an array of integers, it's an array of integer pointers. What was the one more thing we are trying to find the difference with? This one, star C. I'll put the same constructs or 2-3 constructs. Okay, now what will be the size of this C? Now let's see the rule we applied. C, you start with C and then we spiral it, we encounter the closing bracket and we go to the opening bracket. Before that we encounter this thing. So this is a unit. C is a pointer, and then again spiral goes to a multi-dimensional array containing integers. Now I am trying to print the size of C. What did I say? C is a pointer to a 2D array of integers. Okay, so this is a pointer to a, I'll just put this in a bracket. So C is a pointer to a 2D array of integers. Now 2D array, this is a 2D array. So 2D array, so totally 6 elements are present in this 2D array. Each element size is 4 bytes. So that means 6 into 4, 24. 24 bytes. C points to 24 bytes. But what is the size of C? C contains address, single address only. That single address will be pointing to a chunk of memory. The chunk of memory is 24 bytes. But what was the C's size? C is storing only one address. That means it is just 8 bytes. Okay. So I'll put a backslash on. See, it is 8 bytes. Okay, 8 bytes. Let's go on by one. Now, what was this content? It is, if I do a value at, what is this value at C? Value at C is, what is the value at C? Size of value at C. I'm not resolving anything, right? But C's default is 1. We don't have a valid address for that. Okay. C is designed to point to 2D array. Okay, what was the size of value at C? What was C pointing to 2D array? Okay, 2D array size is 23. It should be 24. So if I do a size of star C, it should come 24 bytes. See here, 24. I'll put the backslash in for this. So C is pointing to a 24 sized array. So the contents value, so it is 24. 24 pins for this. Okay. The value 24 is the size. These are bytes in nature. By default, if I print C, it is 1. That you know. Okay. That also I'll put it in one place. Okay. This is default value. As of now, it is 1. What is the content of C? C is having a default value 1. Okay. This is all size of. Okay. Now, if I do a 2-level dereferencing, okay, what happens? C is pointing to double star, size of double star. Now, C's content, C is pointing to a 2D array. What is the 2D array size? 24 bytes. If I do a 2-level dereferencing, C points to a 2D array. One more drill down, if I go further inside, that means 2D to single D. What was the single D size? 3 elements, 3 into 4, 12 bytes. So here in this case, it will be 12 bytes. You see it is 12 bytes here. 12 bytes over there. If I drill down further, it will start moving inside the single D. That means inside the three elements, one by one, that means it is 4 bytes. So if I go one step further, it will be 4. Okay. See here, it's 4 bytes. Okay, having said all these things, let us understand with one storage value. Then we will see with example by storing certain values inside the arrays. I will show on a sheet like this. See here. Imagine there is an array, there is an integer array. Okay, I'll store values like this. For this one, we will have values. Same values here, 847. So it's a 2D array containing 3 single D arrays. Okay, so it's containing 2 single Ds. Sorry. 2 single D. Each single D contains how many elements? 3 elements. 847 will store. 847 593. We have these elements present in this array. Okay. Now the array name is A. I put this one A here. The array name is A. Okay, see this name of the array is A. Okay. Now it contains all these elements. So since we have seen all these, we will remove these things. Okay. Right. Now you see here this all the data. Okay. Now the starting address, I can imagine it to be a 510. Okay, now if I want to print this one, what is the starting address in my computer? %d starting address A. I'll just comment out all the other things. Okay. The starting address is this one for me. Okay, 6487552. That's the starting address A. But here the starting address, this is the name of the array. Name of the array is nothing but the starting address 510. This is called the implicit pointer. You cannot change this binding. This is a binded one. This is the implicit pointer. A is said to be implicit pointer, or array name is a implicit pointer. You cannot change it. You cannot do A equal to A plus 1. A will always be pointing to 510. It's a const pointer. That means A will be 510 always. So for example, if a Python is assigned in my example here, you cannot change the value of A afterwards. It's a const pointer. So now this is a thing. If I do A plus 1, where it will go, the difference I want to just to bring it about for you. If I do A plus 1, it's address. 510 is address. If I do address arithmetic, where it will go? Okay, you see here, A is I'll put one more A comma A plus 1. Okay, so A is pointing to 510, and this is a 2D array. 2 single D's are present. Each single D size is 3. That means this is one single D. Okay, let me change the. So this is one single D. This is another single D. Right? This is one single D. This is another single D. If I do A plus 1, it will go to the next single D. Okay, see the address movement. It will move exactly 12 bytes. 52. This is 64. So if I do A plus 1, if I do A plus 1, A plus 1 will go here. This will be A plus 1. This is A. If I do A minus 1, it will go 12 bytes the previous. A plus 2 means it will go to 5. This is 510. 510 to 12 bytes. It will go. Okay. 2, 3. 12 bytes. It is going to 22. So 22 plus 12 bytes. It will go to 36. Okay, we'll go to 536 if I do A plus 2. This is how this array name value will do, because it's a implicit pointer, as I mentioned. Right, name of the array will move like this. Now this is, we already know, most of the time we have done coding like this. Okay, now in this case, if we do I'll remove all these. You might have seen this. Okay, now this is a array of integer pointers. What is this? Star B 2 3. Now this is what I declare. B is a name of the array. It's an array of pointers pointing to integers. Array of pointers, each of them is pointing to integers. How to do that? Imagine I declared a b. Okay, b 2 3 6. B is a 6-sized array in a 2D fashion, each containing a pointer, and that pointer points to integers. So it's an array of pointers. That means 8 bytes. So if it starts with 610, next one is 618. Here see this one 510, 514, 610, 618, 626, 634, 42, 50. 8 bytes, 8 bytes. It will for each data. 8 bytes will be allocated. So what it stores? It stores the address. That address points to integer. Maybe I can store like this. 514 I can store. This address points to an integer, 4 bytes. From 514, it will try to go 4 bytes. 522, I can store randomly. 510, okay, some other value I have. Say for example, if I declare int m equal to 100, I put somewhere here. This is m is having 100, okay, and this m starting address is say 780, okay, address is 780. That means I can put 780 also, one of the value, right? 780 is a starting address. This 100 is a data, or I can just put 10,000 as a data. 780 is a starting address. I can put that one. 526, I can put this one. I can again put 514, okay, like this. So this is an array of pointers, okay. Array of pointers means array of addresses. That's what the meaning, because this is a pointer. 610 is a pointer variable, okay. This is a b of 0. This is b of 0, b of 1, b of 2, b of 3, b of 4. That's a variable name. B of 0 is a pointer variable. What it contains? Address. B of 1 is a pointer variable that contains 522. That's address here. B of 2 is this. This is B of 2. B of 2. That and all you might be knowing. So it's address of B of 2. Starting address is 626. B of 2 is containing 510. 510 is address, and it is pointing to an integer. Okay, that's what this is about. So if I do in this case the same way what we have done earlier, if we do b and b plus 1, let's see what happens. B and b plus 1. Backslash over here. You see, this is the second one is a printing. So 0 4, okay. B and b plus 1. This is 0 4 504 528. Okay, see this one. How many elements it is moving? It is you see here. This is b. Okay, b plus 1 means it will go to b plus 1 here, because this is a single d. This is one single d. Okay, so b plus 1 means it will go here. So how much it is moving? 1 2 3 8 plus 8 plus 8 24. Okay, so 0 4 plus 24 you will get a 528. So in the actual addressing it moves like this. So this is what b plus 1, then b plus 2 will be, again it will move 24 bytes. It will be 658 address. 658 it will be, but it's going out of bounds of the array. It's not a good way to do that. So I can do b plus 0 or b plus 1. That's fine. So in these two cases, so this is how it is moving. Okay, now what is we are trying to discuss is what is the star C. Now I put something, I'll delete this one. There is one thing you declare. What did it say? C is a pointer to a 2D array of integers. This is a 2D array of integers. It's a pointer to the spiral rule as per the spiral rule. So here you see this one, C contains, I just declare by default, what is the value of C? 1. That's why I put 1 over here. The default value of C is 1. Okay. So, but C will be, this is, what is this 1? This is address value. Default address value, because C is a pointer variable. So this is a pointer variable, its default address is 1. Okay. Now we want to make the C pointing to a 2D array of integers. What is our 2D array of integer? This one. This is a 2D array of integers. I can make the C point to this one, phi10. If you put phi10 over here, see this one, C is pointing to a 2D array of integers. Okay. So we can make this, we can access these arrays. So array values using this. But one thing is different from using A and C. What is that? Let me see. So if I put a printf for C and C++, you just see what happens. Okay, so if I put C and C++, as I mentioned, the initial value is 1. Okay, so backslash, I'll just compare this. What is the initial value of C? Okay. C and 2. Okay, so the initial value here, so in this case it is showing a 0. Okay, so it can be a 0. And what was this size? There were 6 elements. Elements. Each element is of size 4. So 24, it's going to move 24 bytes. Okay, so it's a pointer. So if it is address is 0, if the address is 0, okay, if the address is 0, C plus 1 will be 24. Why 24? 6 into 4, 24 bytes. It is moving 24 bytes. If I do C plus 3, okay, 0, 42. So 24 plus 24 plus 22, 24. So it is 72. Okay, so 72 it is moving. So it has, what is the initial value plus that much size it is moving. Okay, now if I want to assign, okay, say for example C I am putting equal to 2. Okay, C I am putting equal to 2. What is this value of C now? Let's see. Now I am assigning C equal to A. That means what is this? C equal to A. This phi10 I am putting over here. Okay, phi10. So if I put this one, see here, 6487, that was the value of A. So we printed now that A I am equating to this. Okay, so if you put like this, what happens? So I want to access these values using C. Okay, because it is pointing to that way. But if I do a plus 1, where it will go? If I do a plus 1, it moves. How much bytes it moves? It moves 24 bytes. That's what you have to understand. It's 24 bytes. You see here, it was the same thing. These two are same. Okay, these two are same. Means I am assigning A. So C is also pointing to A. A is this one. That is 36. That's 36. 536. 536. But when I do A plus 1, how much bytes it is moving? Only 12 bytes it is moving. Okay, it is being here. A plus 1. But if I do a C plus 1, it is moving 24 bytes. On 2D array size it will move. One single D size is 12 bytes. 12 plus 12, 24 bytes. So it is moving 24 bytes. So it is going out of that array. I cannot access, okay, the internals of this array. So what we have to perform, this is the thing you have to understand. Okay. Now if I do star C, what is star C? We do one level of dereferencing. Okay, one level of dereferencing means it will move inside the single D's. Now let us see this star C I do. Okay, now after printing this, you see what happens. You see, if I do star C, this is same because it is C plus 0 star off. So that means that these two are same, 536, 536. But here it started moving one level inside this. Okay, inside this. So now it is moving C plus 1, C plus C point to first array, C plus 1 point to second single D. Okay, now if you want to get this further, that means imagine I want to print this 9. Okay, so it is pointing to this array. I put a bracket for this, then plus 1 star. Okay, so now it was see here star C we have done. So it was moving in a 2D, this it is moving in a single D. Star C means one dereferencing, 2D to single D dereferencing has done. When you do plus 1 in single D, one movement, one jump, so this points to 593. Okay, 593. Okay, so it's pointing to this 593, that means the whole as a whole. Okay, then what you have to do, you have to do a 1 minute. Okay, so you are here, C is star C, first star C means dereferencing happened, so it will be ready to move inside the single D's. Then plus 1 means in a single D one hop it is pointing here. Then I will do dereferencing one time inside the single D's, it is gonna go. Okay, after this dereferencing you do plus 1. So after dereferencing it is gonna move inside this. That means if you do plus 1 it will move only 4 bytes. Okay, for this one you put a bracketing value at, okay, value at 4 bytes. I will be exercising the value 9. So here accessing the value 9, right? So this is understanding you should have. So C points to a 2D. Then if you want to make it to I want to explain this one more time for you. Okay, take this one alone, right? Let's submit this. Okay, what's happening? Let's see star C dereferencing. So C plus 1 means it will go to jump the 2D size. When I do a star C, dereferencing happen, it will jump only in single D's. So do we need to jump? Yes, there is one jump. So it crosses one single D. One single D size is 12 bytes. So now it point to second single D, 593. Okay, so that one we are dereferencing again, this star. So it is pointing to 593. If you dereference, it was jumping 12 bytes. Now once you dereference, it will jump only 4 bytes. Okay, 4 bytes. So now it is ready to jump 4 bytes. In this 1 plus 1 means 1 4 bytes it jumped, it is pointing to 9. Okay, that has to be dereference. So it clubs everything, value at that 4 bytes. It got it back. So you say it's a 9 as a value we are printing. Okay, so this is the difference of usage. So this is an array of integers, this is an array of integer pointers, this is a pointer to a 2D array. So if you have these kinds of declaration, this is the way which we will be accessing the array elements. I hope this helps. Thank you.